very good morning to all my dear students. Children, hope you have seen that video where I explained about why do atoms combine with each other. So ultimately it is in order to get stability, and that stability is gained only when it reaches that octet, when it gains that octet configuration. That means the outermost shell should be completely filled or half filled, that you learn in higher class. For now you understand that the outermost shell should be completely filled with electrons, then only it will get its stability. Okay, so please do watch that video before watching this video, children, because I have explained in detail about the atomic structure and about valency, which is very important in chemical combination, and I have explained there that in order to get this stability, the atoms, the individual metals or non-metals, they tend to either lose electrons or gain electrons in order to get that octet or stable electronic configuration. So today we'll learn about ionic bond. So this is a kind of bond which results because of the transfer of electrons. As I told you that there can be a sharing of electrons or there can be transfer of electrons too in order to get that stability. That's why the atoms combine, as I told you. So here, if the bond is formed because of the transfer of electrons here, then such bonds are called as ionic bonds, and it is mainly it is formed between a metal and a non-metal. So let us know what is the nature of metal. It is electropositive in nature. What do you mean by electropositive in nature? It has the tendency to give away an electron, and what happens when an atom gives away electron? It gets net positive charge. So metals, that's why they are called as electropositive in nature. Okay. Non-metals, on the other hand, non-metals are electronegative in nature. That means they tend to gain, they have the tendency to gain electrons in order to get that stable configuration. When they gain electron, they gain a negative charge, so that's why their net charge is negative. So that's why they are called as electronegative atoms, electronegative they are. So now here this metal gives away electron and a non-metal takes electron. So that's why there is a transfer of electron happening from a metal to a non-metal, and because of which a metal gets a positive charge and a non-metal gets a negative charge. And because of this, what happens? The positive and the negative charges, they attract each other, and such forces of attraction are called as electrostatic forces of attraction, and they exhibit very strong electrostatic forces of attraction which keeps the atoms together, forming they are held together by strong electrostatic forces of attraction, and they form a compound. So such bonds are nothing but called as ionic bonds, and such compounds are called as ionic compounds, children. So we'll learn some examples over here. I will be giving out a small matter regarding the properties of ionic bond. Because of the very strong forces of attraction, their melting points and the boiling points also are very high, because in order to overcome these forces of attraction, you need to provide more energy in the form of heat or any other. So that's why they have very high melting points and boiling points. Along with this, I'll be giving out some more matter, extra information about the different properties of ionic compounds, children. Okay. First of all, let us know some examples here. As you know that it is a bond that is formed between a metal and a non-metal. Metal gives away electron, non-metal takes that electron in order to get the electronic stable configuration. So here are the examples. So a metal and a non-metal. Can you see over here? A sodium is a metal and chlorine is a non-metal. Sodium chloride is a salt that is formed. And now this is an ionic compound. Let us see how. Sodium, its atomic number is 11. Already I explained all this in my previous video. Please do watch that video. Atomic number is 11. That means it has 11 electrons and 11 protons. We are concerned more about the electrons because it gives the valency. It is nothing but we can assess the valency, we can know the valency by the number of electrons present in an atom, and mainly in the outermost shell. That is nothing but called as the valence shell. So here this is the electronic configuration of sodium. 2 in the first shell, 8 electrons in the second shell, and 1 electron in the outermost outermost valence shell. Now in order to get the stable electronic configuration, it tends to lose this electron. One electron is extra. If it loses it, it gets, you know, the stable electronic configuration maximum, or the most maximum full, the second shell will be completely filled, isn't it? So it gains stability. So always it will be in that, you know, to give away that extra electron. So now chlorine, its atomic number is 17 now. It has got one electron less in order to get the stable electronic octet configuration, right? So this one electron, sodium, it transfers or donates its electron to chlorine. Let us see the representation, electronic dot representation of atoms now. Sodium, what is the, how many electrons are present in the outermost shell? It is 1. So I will be keeping just 1 over here. Now chlorine. Chlorine, it has got 7 electrons, depict as electronic dot configuration. This is called as electron dot configuration, where number of electrons which are present in the outermost shell are depicted or denoted like this in the form of intos or dots anyway. So now it donates this electron, transfers this electron to chlorine. It becomes like this. Now it has got 8 electrons in its outermost shell because it got 1. So it becomes Cl minus. How many electrons did it gain? It gained 1 electron from sodium. So it got 1 net negative charge. It became Cl minus. And sodium, how many electrons did it give away? 1 electron. So it becomes 1. It net charge becomes 1 positive charge it gains. So Na plus and Cl minus. So you can see that the positive and the negative charges, they get this electrostatic forces of attraction acting between them, and they both are held very strongly with each other, and they form a compound sodium chloride. Now you see, when it is gone, it has got its octet configuration. It is much stable now. Chlorine, it has gained 1 electron. It is now attained stability, right? So Cl minus and Na plus both are held by electrostatic forces of attraction. That is how an ionic bond is formed between Na and Cl. Okay. Now MgCl2, let's see another example. What is the atomic number of magnesium? It is 12, children. Atomic number is 12. So how will you represent it in the form of electronic configuration? First shell 2, maximum number of electrons, and then second shell 8, and how many are left? 2 are left. So 2, 8, 2 is the electronic configuration of magnesium, and chlorine, it is 2, 8 and 7, as we have already seen over here. MgCl2, that means, let us again write down magnesium electron dot configuration. How many electrons are present in the outermost shell? It is 2. I am representing it in the form of a small into. Then we have chlorine. 2 chlorines we have. Let us see. One chlorine has 7 electrons. Another chlorine also has 7 electrons. Now this chlorine needs 1 electron. This chlorine also needs another electron. Oh, luckily we have 2 electrons with a magnesium. 1 electron it transfers to 1 chlorine atom. Another electron it transfers to another chlorine atom, such that bonds are formed. Now what is the net charge on magnesium after the transfer? How many electrons are getting transferred here? 2 electrons. So it gets net 2 negative, 2 positive charges. And here chlorine, how many atoms are there? 2, and they get minus, net minus electron charge. So here also 2 positive and 2 negative charges. There will be I can put it like this, Cl minus whole power 2. That means 2 chlorine atoms are present with 2 negative charges and 2 positive charges. They will again have these strong forces of attraction between them, which holds the molecule together, holds the atoms together, forming a strong molecule. MgCl2 is another example of ionic compound. Did you get that? So will you now try and just show the formation of ionic bond in case of CaCl2 and CaO, children? Try and send me the pictures, okay? CaCl to calcium chloride and calcium oxide. It's very simple. You have to simply know the atomic number of calcium, write the electronic configuration and see how many electrons are getting transferred. Okay, calcium oxide and calcium chloride, and tell me the answer. In both the cases, calcium is the metal and chlorine is a non-metal here and oxygen is a non-metal here. Here also an ionic bond will be formed. Okay, this was the last topic from your lesson, children. For this year, the metallurgy, the metallurgy topic is completely deleted from your syllabus. So till here you will have in the board examination the syllabus of chapter 3, metals and non-metals. Up to here only you will have for the examination, children. So ionic bond is the last concept to be taught in this